Everyone. So here we continue our journey working with strings and text. So last time we learned how to work with some words and identifying words that are uppercase, words that are digits, words that are alphanumeric. We also worked with some text and we were able to split the text into words. So today I would like to give you a really nice practical example of working with text and how we can put these built-in functions that manipulate strings into action. So we can see how useful these functions are when we actually work with text. So here we work with data I collected using the Twitter streaming APIs to be able to analyze data from tweets, analyze them in the most simple way possible. So I have a file here that I'm going to open, and I believe it's called tweet something something, and then my Jupyter notebook is very kind to me and it's recommending the file that I need to open. And here I'm opening the file and I'm gonna get a file reader like that. And we definitely understand what that does. Basically reads the file, gives you a file reader here, and then from the file reader we can read all the lines all at once like that. And this is gonna give me like some sort of an iterator. If I immediately and let me just print the type here so we know what sort of data type that we're working with like that. This is an expensive operation, so it's gonna take some time. Oops, I think we might have a little. Okay. Okay, so it's gonna do a lot of reading here. Is gonna read all the lines into memory, and then is gonna return some sort of a type after it reads. Clearly, like I said, this is an expensive operation. I wouldn't do it all the time. It's essentially a list. So what is given me already here is a list that we can actually call it tweets like that. So if I work, I'm gonna run this one more time, and if I measure the length of the list here like that, I want to measure the length of the list. That's what I meant to say. And this is going to give me how many tweets in the well, we need to run it one more time, and this is again gonna take some time, but we understand it is an expensive operation, and usually I wouldn't do it this way, but it's just one simple command that you can run. And then if we for some reason file reader is supposed to be giving me one more time here like that and like that. This is supposed to give me the tweets all together, and like I said, it's gonna take some time. And then one more time, here we go. So this is the number of tweets that we have in the list of tweets. So if I want to inspect maybe the first tweet at index 0 in the list, it looks something like that. It's comprised of 3 components, and this is the structure of the file that I chose. So this is my own structure. It's not something that you have to work with if you choose to collect your tweets or collect your data in any other format. So it's pipe separated, not comma separated. So clearly here, if I also look maybe for another one, tweet at index 11. I'm not sure why it's taken some time to read. I don't know. Let's do it at index 0. My Jupyter notebook is not behaving itself today. I don't know why. Here we go. So it's reading this line here. Let me do tweet number 1 like that. Okay, so for some reason Jupyter notebook is just not behaving really well. So what I want to show you is that the first component here is a date. Second component is the actual tweet. Actually, the second component is the person who tweeted, and the third component is the actual tweet. So let's work with this. So if we want to process, say, the first 10 tweets. So I am going to go from 0 to 10. So I'm going because it's going to be a very expensive operation to process all these tweets, and so this is really unnecessary. So this is just a way of slicing the list here. So we're going to read a small chunk, maybe make it maybe 20 or something like that. So working with this, now I'm going to read one tweet at a time from these 20 tweets. And then I'm just going to print the tweet here like that. Well, for tweet in like that. So these are my tweets that I have inside the file. I'm really hoping to see some exciting data. Clear. I don't see any hashtags, which is really strange. Maybe if we make the data set maybe 100 or something, so why not? Like that, then we're clearly gonna see some hashtags. All right. I don't see hashtags still. Let me see here. Like that. Okay, so there are some hashtags. All right. File. Find. I'm gonna find another hashtag here. Okay, so there are some hashtags here. Very good. Reason why I want to show you these hashtags is because I want to show you how to process the tweet. So the tweet has 3 components. Every line has supposed to have 3 components. Some lines are empty. So I'm going to, the first thing that I'm going to do is to split the tweets based on the pipe here. There is a pipe, as you can see. My tweet components are constructed using a pipe as opposed to comma. You can do anything you want with your data, and that's how I chose to do it. I have my reasons, but you don't have to worry about that. So these are the tweet components like that, comps. So now I want to make sure that every line that I read is actually comprised of 3 components, because if I try to say this line here, which happens to be empty, and I'm trying to access the components of this line, and this line only has 0 components, I'm just gonna get and I'll show you here. So now if I show you here like comps, I want to get, say, the date. The date will be at index 0, like that. So let me show you, or maybe it's called the timestamp. That's what the proper name for it. So if I do that like this, right, we can see the timestamps for every one of them. And as you can see, some of them are, they don't have timestamps. Okay. And if I say give me the actual tweet, we might not have the luxury of taking a look at an actual tweet, because the tweet here does not have 3 components. When we broke it, it only there was that tweet at this line here did not have the 3 components. So what we need to do is to make sure that if these components are exactly 3, if the size or the length of the components of the tweet are exactly 3, like that, then I would like to print the tweets that I would like to print the actual tweets like that. And this is not going to give me any error here. This is going to give me exactly the tweet that is part of the record where I recorded the data by the person who tweeted, and by the timestamp and the actual tweet. So we can also capture the person who tweeted. Now we can say like that, person tweeted, like this, and the person tweeted is gonna be available at index, the second place, which is index 1, like that. the person this tweeted, the person this tweeted, like that. Now we are able to see the actual um, person who tweeted. Okay, but as you can see, we also see inside every tweet, there are people who are being mentioned or being retweeted. Is there a way that I can construct the mention, say a list of mentions between the original person who tweeted, and the person who's been retweeted? So this is the person who tweeted something, and the person now who tweeted this tweet have retweeted this person. So we want to say if the tweet here has a person who has been retweeted, I want to see who tweeted and who retweeted, which will be a really interesting thing to do. So instead of printing things randomly now, I want to be able to print the original person, the person who tweeted. So that would be a person component at index. Well, before I do that, I'm going to analyze the actual tweet and see if it actually contains. So I already know that the actual tweet will exist at element at second index of the element here. So this is my tweet text, like that. And now I can take the tweet text and I can break it also by space split, like that. If I don't do anything with the split function, I don't pass anything to it, is going to break the actual text to words based on spaces. So any space here will break these words. And let me show you here. So these are the words of the actual tweet. And if we actually print the words, print just the words like that, and then to separate the tweets from each other, I'm just gonna make a line here so you see every tweet with the words. And as you can see, it breaks it and it gives me a list of words. Well, these words might actually have people who have tweeted or been retweeted. So we can here also ask. So when I have the words here, if the word, so I can basically loop over these words for each word in words. Now, if the word here, I'm gonna use a function, a really interesting function, very useful, starts with, we've seen that last time. If that word starts with an @ sign, then we grab the word. So here, when I mean grab the word, we can just print the mention. We call this the mention. Because here the person was mentioned in the tweet, so this is actually called a mention here. So this word here happens to be the actual handle. So I'm going to uncomment this. So we're going to see the mentions here, and I definitely need to put a colon here. So as you can see, here are all the mentions and all the tweets that people have been embedding to mention somebody in their tweet. The mention could be a reply. It could be a simple mention. It could be basically just, I want to grab your attention, so I'm mentioning you by your handle. Or I could be retweeting a tweet you've done, so I will still consider your handle to be part of my original tweet. All of these things are considered mentions. Now I want to construct, say, a pair of the person who actually tweeted originally and the person who's been mentioned. So how do I do this? Well, it's really simple. We already know that the person who tweeted the original tweet exists at index 1, right? And we already know that this word here starts with an @ sign, therefore it will be a mention. It will be another user. So if I print this tuple just like that by itself, it's going to give me two different components. the person who tweeted and the person who's been mentioned. And as you can see, every one of those guys or some of them has a colon. So why not we use another function to get rid of this annoying column here? We're gonna use the strip function like that, and the strip function we can pass anything to it, and then it's going to clean it from the two ends. If I say right, is gonna clean it from the right. If I say L strip like that, is gonna clean it from the left, and if I don't say anything, is going to clean it from both ends. And now all I care about is to clean it from the right, and I want to get rid of all the annoying columns here. So this is why I'm gonna call it the L strip here from the right. And look at here, remember that we had these annoying things. As soon as I run this is gonna disappear. And I lied, it did not disappear. Well, let me see why this is not working. Well, because I did it from the left and I'm supposed to be doing it from the right. And now, as you can see, we've gotten rid of all the annoying things. So now we saw how useful using some very basic built-in functions, string functions, that can give me some very interesting information about the people who tweeted. This is a foundation for constructing networks, and this is how people actually work with networks in the world of network science and social science. They use very basic ideas and very basic functions like this one here. And I'm going to also show you another interesting function, because this word could start with an @ sign. It could start with anything else. So why don't we just ask if this word also starts with a hash sign, and that will make that word a hashtag. So I am going to copy this here, and I'm gonna clean it in the same way. And now I'm going to print, so that would be, let's put a really nice, so person dash hashtag like that. And here would be a person dash mention. Or we can say person to person, whatever it is you feel comfortable with. But I wanted to make sure that you see the difference between these two things. If we run it, as you can see, we have very little hashtags, but we do have them when they show up. And as you can see, some tweets don't have anything at all. All right, you see, and two lines here, dotted lines back to back, which means that the tweet did not have any mention or any hashtag. And here there is a tweet that actually has more than one person to tweet, and also a hashtag. So let's take a look. Yes, let's see. So this is a very rich tweet here, a tweet that has the person mentioning more than one person here. And here is also another very interesting tweet where the original person has tweeted something or mentioned the person, ABC Amba TV, and then the person also tweeted two different hashtags and included two different hashtags in the tweets. You could always ask yourself something else. If the word, like say, you want to also identify, oops, you can also try to identify like tiny URLs. So if the word starts with else if the word starts with HTTP like that, then we actually want to see the tiny URL that was been embedded inside the keyword. And here I'm not gonna bother stripping anything, because usually the URLs should come clean. So let's do that, and then else if the word, okay, maybe I have a little typo somewhere. Okay, I'm not sure why it is invalid. Okay, and then let's do else. I'm just gonna pass here. Okay, I think I understand because we were missing the closing for the keyword here. It's still not liking. I'm not sure why it's not liking it. Are we missing something? We're probably missing this one here too. Okay, there we go. So let's see if we have any URLs. Do we have any URLs? It does not seem like we had any URLs. HTTP. It did not seem that we have any URLs. Oh, actually we do. Here we go. We actually do. Well, the reason why it was not showing up here because we made it about HTTP and then column versus HTTPS. There is a secure HTTP protocol versus the version of HTTP. Clearly, HTTP itself is probably almost nobody using it because it's not secure. So, but anyways, now we see that we capture all the HTTP protocols here, and then if you resolve these, if you resolve them, let me see if I can switch the screens. I hope it's not something nasty. I haven't seen those guys. Well, I'm glad it's something. It's probably something related to the coronavirus, or I don't know. Yes, it is something related to the coronavirus. So I'm glad it's not something that I had to worry about. I never tried them. So the tiny URLs here can actually point you to external resources, and then you can also work with these tiny URLs after you resolve them, and then you get the data from inside and then you analyze. This is a very simple demonstration, you guys. I wanted to show you how little functions that we used and how powerful we could do with the kind of basic Python functions that we can as built in. We can basically work with them. We use the split function here. That's number one. We used it again. We used the function called start with. We used the strip. We can also ask if a word that is, we can, as a last thing, we can say else if a word equals, say the word sad. And here, suppose there is a word with an uppercase sad or lowercase sad, then when we call the function here, that's called sentiment found, you can say sentiment found. I'm really doubtful that we'll find anything, but we can run it one more time. Well, I need to put a colon here like that, and I don't know if we have any sentiments. We don't have sentiments, but I bet if we increase the limit here, maybe with 1,000 or something versus 100, we might be able to see a sentiment that says sad. But the reason why I wanted to show you this is because I want also to use a couple of other functions and also run the string equality. Maybe if I actually do this as if like that, and I'm going to comment this. We have not found anything. Oh, there we go. So clearly we can also identify sentiments as well in the tweets when they exist. Even if I reverse back to that, that's going to give us the original thing. Okay, this is good enough. This is really good. Feel free to let me know if you still have any questions. If you have any comments, shoot me an email. And as always, thanks for watching.